Now let's move on to the next unit 3, database management system. This is a totally new concept for you all, and we need to understand the basics of this particular unit. What actually is database management system? Before understanding what is database management system, we will have to understand number of other things which are involved in it. So let's understand what is database management system. For that, we will have to first understand what is data. Data is something which is in the form of facts or figures. It could be a name of a person, it could be age of a person, it could be class, it could be marks, it could be subject, anything. So if I say Vishal, this is data. 87, this is data. B 176, this is data. If I say Delhi, this is data. All this data may or may not be meaningful. The raw facts and figures which may or may not be meaningful is called as data. The next is information. Now, what is information? Information is the processed form of data which is meaningful. So once we have done some processing on the data, we had some data available with us, and now we have done some processing on that particular data. And now after processing, information which we get, that has got a specific meaning. It's meaningful. It's useful for us. That's called as information. Nowadays, everything is going to be data driven. You must have already heard about artificial intelligence. Artificial intelligence, the basic concept there is data. It keeps collecting the data over a period of time, and based on that, it learns how to take the decision. So all the information processing which is happening in artificial intelligence is based on collection of data. So that's the importance of data. Initially, it is meaningless, but when it is processed properly, it becomes meaningful. For example, let's process this data which we have got, and let's see. Now this becomes a meaningful information. Now I know that I'm talking about a person whose name is Vishal, and he is resident of B176, Delhi, and his age is 87. So this information is meaningful to me now. So that was about the basic terms called data and information. Now we move on to the next. We normally store this data with us. Say, for example, you would like to store the data about your friends. You would store their name, their address, and their telephone number in your telephone directory. But normally what happens is that when we create this kind of a situation, we have an address book with us where we are storing the details about our friends. We keep adding it in that particular diary. So we have added, suppose today I've got 5 friends. So what I do is I'm just going to add their name and address and telephone number in my address diary. So I add the name and address over here, my first friend. Then I have another friend. So I'm going to add his name over here, his address over here, and his telephone number over here. Like this, I'm going to keep on adding the name, address, and telephone number. But you have to imagine that you're doing this manually in your address book, not on computer. You're not using computer for this. You're using your diary. You're using your address book for doing this. After 5 friends, you have discovered or you have found 10 more friends. And now you would like to add their details also. So you keep adding it over here. After you keep adding it over here, your address database, your address book grows, and you've got 100 friends with you, and you've got details about 100 friends in the address book. Now, the real problem starts. The problem is that if you would like to search for one particular friend, what do you have to do? You have to go through all the pages. You have to start from first page where the address of that particular friend is. You cannot directly go to that particular friend name, even if the name of that particular friend is starting with A, because in the manual diary, you cannot arrange them in alphabetical order or in any other order. It is coming as the first come first serve basis. So whoever is the first, his address and details gets entered first. Then whoever is the last friend, his details get entered last. In the manual thing, you cannot rearrange all this thing. It's very difficult. You will have to strike it out and then write the whole thing once again, arranging in alphabetical order. And then by chance you discover 5 more friends, you had it. You will have to strike out everything and then rearrange everything once again. So it's very difficult to rearrange the whole thing in manual system. For that, we discovered that computers can be used for doing this easily. So we designed something called as database management system. So now the term must be very clear to you. We are talking about database and we are talking about managing that particular database. Now, a system which has been designed for managing this particular database, that particular software system is called as a database management system. There are a number of software systems which are available, which can be used as DBMS. The short form for this is DBMS, Database Management System, where D is coming from data, B is coming from base. So the advantage of using database management system is that it provides us the facility to arrange all our details in a systematic manner. And it gives us the system of looking for those particular information, looking for that particular data, and arranging that data as I want, deleting some records, deleting some data, or adding some data. A database management system is a software package with computer programs that controls the creation. So it will help you in creating a database. It will help you in creating a structure for you where you can store the data. It will help you in maintaining that and using of that entire database. So it allows organizations to conveniently develop databases for various applications. Now, where do we normally use this? We normally use this wherever we have got to store the data, wherever we have got to keep details about the various things. We talk about the data in school. We have to store the details about the students. It's not only students, you have to store the details about the teachers. Apart from that, you have to store the details about the items which are available in the tuck shop. You have to store the details about the books which are available in the library. Details about the items which are available in the store. Details about the employees who are working on campus. So you see, you look at one situation, school, and you can think about so many databases. To help in this, we have got various companies which have come out with their own databases, their own DBMS programs, their own DBMS softwares, applications, which can be used. Some of the examples, some of the well-known ones are Oracle. So this is one of the very well-known DBMS, that is Oracle. The other one is IBM DB2. Then we have got Microsoft SQL Server. Then we have got Microsoft Access. We have got PostgreSQL. We have got MySQL. We have got Fox Pro, and we have got SQLite. Plus, the one which we are learning right now. The one which we are learning right now is the OpenOffice Base. So the name of that particular software we are learning is OpenOffice Base. So we have got OpenOffice Base as the software which we are learning as the DBMS in OpenOffice. Now, when we talk about organizing these the databases, we can organize it in two different ways. One is flat file and the other one is relational. What is flat file? The data in a single file, which could be with the help of separated by comma, which could be separated by special characters, or it could be arranged in one single file. So we were talking about only one file to be stored. So data was stored in one single table in flat file. But then we started realizing that this concept can be implemented in a much better way for different domains. Now we are talking about domain. So domain is one area to be considered as a database. Say, for example, school will become one domain. An organization will become another domain. Say, for example, Reliance will become one domain. Under Reliance, we will have many tables. Tata will become another domain. So we came up with the concept of relational database management system. So in relational database management system, we started thinking about more than one table. So the data got stored in multiple tables, and these tables were linked with each other. Say, for example, I'm talking about the school. Then we have one table of students and another table of teachers. Now this is going to be linked, because when we talk about students learning from different teachers, so we are going to be linking up this particular table. Students going to the library and issuing the book, so we will have to link up the library table with the students table. So these tables got linked with each other, and this concept is called as a relational database management system. And this is suitable for large amount of data. Now, the next concept is database server. What is a database server? It's basically a computer, a machine, which is dedicated only for this job. So this particular server is not used for doing something else. It's only used as a server for providing the services to all the other clients. Whoever is going to ask for any information, this database server is going to provide that information, right? So it requires a dedicated processor. It requires a dedicated machine, because as the database is going to keep growing, the requirement of the users will also keep growing, and there will be heavy pressure on that. For example, if you talk about the railway reservation, the train reservation thing, they use a dedicated server. They use a dedicated computer for this purpose. And in some cases, they use more than one machine. They use parallel servers. So there will be 4 or 5 servers which will be providing the services. There are two concepts involved over here. One is called as front end and the other one is called as back end. See, what happens is the front end is the graphical user interface. So this is your front end. I think I'll use it in the other way. I'll keep the front end over here. This is the front end. Okay, so you've got this front end. Front end is a graphical user interface. Front end is something which is going to interact with the user. So you have something with the buttons, with the text fields, with the pictures and all that. That's called as a front end. And that is normally designed using a programming language like Java or Python and all that. Depending upon which language you're using, Visual Basic can also be used. So that's the one which is interacting with the user. Then this front end is going to take the data, it's going to collect the data and pass it on to the back end, the database server, where the data is actually stored. So this is called as the back end. This is the back end and this is the front end. Then if the user requires any information, the user is going to request for that. And from the database server, the information is going to be picked up and given to the front end where the user can see the information, where the user can see the results. You all are using this front end and back end concept every day. Where do we use? All your the screens which you're seeing right now, the Gyansagar portal. The Gyansagar portal, when you log in and the screen which you see, that's all the front end. It has been designed using a programming language which provides the graphical user interface for the user to interact. All your data, your marks, your details, everything is stored in the backend. That's the server, the database server, which is not visible to you. You don't see the backend server. You don't get to know how the data is stored, what is the table structure. Nothing is visible to you. What you are seeing is only the front end part. This is visible to the user. Now, this type of access is referred as client-server model. This is called as the client. You are the client, and this is the server. The server is going to store all your data. There are certain advantages in using the database, in using the DBMS. What are these advantages? The first advantage we have is reduced data redundancy. What does data redundancy mean? Data redundancy means duplication of data. You know, normally, many times you would have observed that your information is stored with one teacher. You give your name, address, and telephone number to one teacher. The teacher stores that information. And the same information is stored with another teacher. That same information is stored in the library. The same information about the child is stored in the office. So the same information is stored at 10 different places. This is called as data redundancy. Duplication of data. Duplication of data, the redundant data, which is stored at 10 different places. That can be reduced by using DBMS. We can store the data at one place itself, and that data can be shared by everyone. So that's about the data redundancy. And the second point is also explained, sharing of data. It's stored at one place and it can be shared by as many people as we want. Then you've got another concept which is called as data integrity. Data integrity means if I'm having, say, roll number 123. Roll number 123 is of the student Shloka. Now, in the office, roll number 123 is of Shloka, but in the library, roll number 123 is of someone else. That is inconsistent data. So when you're using the DBMS, you can maintain the integrity of data. Say, for example, if roll number 123 is of Shloka, and when he goes to the canteen, he is getting his things issued from there. He has got to give his roll number. The moment he gives the roll number as 789, if we are using the DBMS, if we are using the database management, we can easily come to know that, okay, 789 is not the roll number of Shloka. It is the roll number of someone else. So whatever entry we are going to make is going to be the wrong entry. So we can cross check. Validity of data can be done at that place, right? So that's what is called as data integrity. Then we have got data security. Of course, with the help of this, we can have the user ID and the passwords. Like, for example, you've got your user ID and password for your portal. In the same way, whenever we are using the DBMS, we can always have the user ID and password for the users to access the database. Not everyone else is allowed to access the database. Only the authorized users are allowed to access the database. And in that also, we can provide the access. That means the services to the different users based upon what their use is going to be. So we can provide different rights to different user. Say one user is the one who is supposed to enter all the data. His job is only to enter the data. His job is not to see that who is in class 10B and who is in class 12B. His job is that this is the details of the student and it has to be entered. So the rights will be given to that particular person only to enter the data, and he cannot see the data and he cannot modify the data. He cannot delete the data. So you can have different kinds of security level. As an administrator, if I want to see the records of all the students, I have the security rights, I have the rights, and I can see that. But as another user, as another teacher, or as another student, you will be able to see only your data. You cannot see the data of other students. One teacher will be able to see the data of students of their class. They will not be able to see the data of students of other class. Okay, so that's about the data security. This all can be maintained with the help of the passwords, with the help of the user ID. Privacy, of course, I've already talked about this. The information which is private to one particular user, we can maintain that privacy with the help of user ID and passwords and all that. And this need not be shared with others. So you can have the privacy of data. Backup and recovery can be maintained. Normally with the DBMS and RDBMS softwares, you don't have to bother about backing up your data. You can just schedule it and the software will automatically take care of backing up of your data. So just in case there is some failure because of some reason, could be the hardware failure or could be any other reason, malware attack or anything, you can still recover your data from the backups which have been stored. In most of the large organizations where the data is very important, they normally have this kind of a backup and recovery system. Items which are stored in the shop, the inventory control, the inventory stock which you have, all that data is important for them. So they will keep backup of that. Data consistency. Data consistency, as the word indicates, consistent data at all the places. You must have observed that as I was giving the example of in the beginning, that your details are still stored or maintained by 10 different teachers at 10 different places. You will find that you made a correction in your telephone number or in your address or in your email ID, and you told one teacher. Now you find that the other teachers are not aware about it. That's because you were not using the features of DBMS. You are relying on individual information. So that data has been changed at one place, but it is not changed at all the other places. Then you will go and inform the other teacher will change it. But the rest of the 8 teachers, they have got the old data. They don't have the new data. They don't have your new telephone number. They don't have your new email ID and all that. That is called as inconsistent data. This inconsistency can be removed and we can maintain the data consistency with the help of database management system, because you have got to make the change only at one place, not at 10 different places. 10 users are using, but the data is only at one place. So this is your database server, and this database server is catering to 10 different people. Everyone is accessing the same data from one source. It's the same river from where everyone is getting water. So if that river is clean and maintained, everyone gets pure water. Let's go on to the next slide. There are certain terms which you have got to learn about. There's something called as database. Now, database is a term which is used in context of large quantity. So when we talk about database, we are talking about reserving an area for you. So if you give the name of the database as Reliance, this area is reserved for Reliance. If you give the name of the database as Tata, this area is reserved for Tata. Okay. And if you give the name of database as say the Saga School, this area is stored for the Saga School. Within these databases, you can have number of tables. So within one database, I'm going to create one table, and I can create second table, I can create third table. I can create as many tables as I want. Now, what are these tables going to be? These are the tables which are related to that particular domain. They are related to that particular area. So if I'm going to be storing tables in this Reliance database, I'm going to be storing the tables which are related to that particular company. So I'll be storing the details about the stock. I'll be storing the details about the employees. I'll be storing the details about whatever related to that particular company. It will not have tables which are related to the Saga School. It will not have tables which are related to Tata. This particular database will have all the tables that are related only to this particular company. So once you go inside the database, you have all the tables which are related to that database. They are available to you and you can work with them. You can maintain those particular tables with the help of the writes, of course. There are different commands, and when you are dealing with the softwares like Base, you have got the graphical user interface. You've got those menus and the screens with the help of which you can work and maintain these tables. You can add records to this table. You can create new tables if you want. So for example, over here, I have given you, this is the database of the school. Normally, a school database would have different tables. One table could be for the student. One table can be for the teacher's details. One table could be storing the library details, the book details, details of the members to whom the book has been issued. Okay, new books have been purchased. So all those things will come for the library. You can have more than one table for library. That's not a problem. You can have canteen table. You can have store table. So all these are the different tables stored within one database. So database is a big container which is storing different related tables within it. So the term, if we have to define, a database can have one or more tables. Each table in a database contains information about one type of item. So for example, student table. Student table will store the information about the students. So a database is a container that holds tables and other objects and manages how they can be used. That's the definition for database. Then we move on to the next slide. Tables. What are tables? As we talked in the previous slide, one database can have number of tables. Then what are tables? Tables are the basic structure where the data is going to be stored. Now, normally in a table, we store the information in the form of fields, in the form of the columns. Say, for example, I want to store the roll number of the students. So roll is one field or one column in my table. Is that the only information I want? No, I want the name of the student also. So name of the student is going to be the second column for me. So if there are 20 students in my class, I'm going to have 20 roll numbers. And each roll number will be considered as one record. I have got the second field. So this is, let's see this as example. This is one field, which is roll. And this is the next field, which is name. So when I have the roll number 1, 2, 3, 4, 5, like this each one is considered as one individual record, one individual entity. So this is one record which we have got. How many records are there? There are 5 records over here. How many fields are there? There is only one field over here because I've got only roll number. But if I have name also, then I will have 2 fields in this. Now, this 1 and A together will make one record. This 2 and B together will make one record. So records are made up of columns. They are made up of number of fields, the item in each field, the related item in the fields. So for example, if this is 1 and his name is A, This entire thing is going to make one record. 1 and B will not make one record. This is not one record. Okay, this is not one record. This and this is one record when we put this together. So let's define the table. A table is a set of data elements. These are the data elements. One, this is another data element. Is a set of data elements or values, which we call, that is organized using a model of vertical columns. These are the vertical columns which we have, which are identified by their name. So the name of the column is role, name, class, marks, like that. And horizontal rows. So horizontal rows are these. These are the horizontal rows. A table has a defined number of columns. It has a defined number of columns. It has got a fixed number of columns. So when we define the structure of the table, that time itself we decide that these many columns I want in my table, because I want this much of information. When I'm talking about the book, I want to store the book number. I want to store the title of the book. I want to store the author of the book, and I want to store the price. So how many fields do you have? How many columns do you have? I have got book number, author, title, and price. So there are 4 columns in this particular table. But it can have any number of rows. So a table has a defined number of columns, but can have any number of rows. There can be many rows in a table, because you don't know how many books are going to be there in the library. There can be 10 books, there can be 20 books, there can be 100 books. So there can be number of books in the library. So the number of rows is not fixed. That can keep on increasing or decreasing depending upon how many books you're purchasing. That will keep adding. If there are books which are lost and they have to be removed from the library, that will be deleted from the table. So the number of rows are not fixed. Each row is identified by the values appearing in a particular column, identified as a unique key index or key field. Now, we are going to be talking about this. One record, say for example, I've taken the student table over here. The student table, we are storing the roll number, we are storing the name, we are storing the class, and we are storing the house. Each record over here, this is one structure which I have declared. Now, if there are 20 students in my class, I will be storing 20 records. So for each student, I will store the roll number, I will store the name, I will store the class, and I'll store the house. Out of all this, there has to be one field, one column that is going to help me to identify each record individually. It should be a field that is going to be working as the key field. That is going to be unique. That's not going to be duplicated. For example, if I have roll number as 1, I should not have any other student with roll number 1 in the class if I'm talking about the class table. If I'm talking about the school table, then I should not have any student with the same roll number. As you must have already noticed that all of you have got an admission number. That admission number is different for every child. That admission number is the key field, which helps us to uniquely identify every student in the school. You will find that your admission number is not repeated again. Whereas the other fields, if we see, name can be something which is repeated. You can have 2 students with the same name. You can have 10 students with the same name. So in a class, you might have 2 students with the same name. In a school, you might have 10 students with the same name. So you cannot use name as a key field. Key field should not be duplicated, and key field should not be left blank. You cannot have that as blank. So that's the importance of the key field. Class, for example, can we keep class as a key field? If I'm storing the information about students in the school, can we keep class as one of the key field? No, We cannot keep class as one of the key field because there are going to be multiple students in the class. So the class is going to be repeated for 10 students, 20 students, and 30 students like that. Similarly, house is another field which cannot be kept as a key field because there will be number of students in the same house. So when I'm entering the data of 10 students, I will find that 4 of them are in the same house. So house is getting repeated. That means I cannot keep house as the key field. So what can be kept as the key field? Either the roll number or the name. Out of these two, I find that name also should be disqualified as the key field because there can be number of students with the same name. So only roll number qualifies as one of the key field. In case you are talking about the school table and the roll number of the students is getting repeated because we are talking about the class roll numbers, then you should have one more field over here which is kept as a special field as the key field. ID of the student or the admission number of the student, that will become the key field. And this roll number will also not considered as the key field. So that's about the concept of table and the fields. Now we have something called as the columns. I have already explained this, so I think it should not take a lot of time. We have already talked about the columns. So columns are something which store the data value of a particular simple type. Of a particular simple type means that in this is one column which I've got. The name of the column is roll. So every column will have a specific name. So name of the column is roll. What is this column storing? It is storing only a particular type of data, that is the roll number of the students. Let's take the next column, which is name. That's the name of the column. You can have any other name if you want. You can have S name, you can have F name, you can have L name, anything you want. S name, student name, surname. You can have F name, first name, and last name like that. And this is storing only the name of the students, nothing else. Then you've got the class. Class is storing, this is the third column, which is storing only the class of the students. Then you've got the fourth one, which is house. House is storing only the house of the students. So these are all called as the columns. And what are rows? This is row. Now, when we talk about this column, there are certain words which you have to be familiar with. A column is also called as a field. So we can also consider roll number as a field, name as one field, class as another field, and house as the fourth field. So we can either consider them as field or we call them as column. There is a third term which is used that's called as attributes. So three terms are exactly the same. Columns, fields, or attributes means exactly the same. Then we have rows. Now rows, one row, this is one row which we have over here. This one row gives us the complete information about one item. Each row over here is called as one of the items. Now, about each item, we are getting the complete information. If we talk about this, roll number 1, 2, 3, Pramit is of class 7 and is in Ruby house. Roll number 2, 3, 4 is Hardik. He is in class 9 and he is in Diamond house. So each row gives us the complete information about one of the entity. Each existence is one entity. Now, there are a number of words which are used for this. It can either be called as a row, it can either be called as a record or a tuple. So, whether we call it as a tuple or we call it as a record or we call it as a row, we are meaning exactly the same thing. We are talking about one student and his complete information. We are talking about one item in the shop and the complete information about that item. We are talking about one book in the library and the complete information about that library. That is called as record, row, or tuple. So, in simple terms, a database table can be visualized as consisting of rows and columns or fields. Each row in a table represents a set of related data. This is very important. It represents set of related data. This can come in the multiple choice question. They can say that what kind of data is represented in a row. It is related data. A data which is related to that particular entity we are talking about. And every row in the table has the same structure. That's very important. You cannot have the different structure for each row. Say, for example, for first student, I'm storing the roll number, name, class, and house. And for the second student, I'm storing roll number, name, telephone number, and email ID. That is not done. We have defined the structure of the table. This is the structure of the table. And every time, all the students' records which I'm storing will follow the same structure. Every time, I will be storing only these 4 information. I will not be storing anything else. I will not store, if my structure does not permit to store the telephone number and email ID, I cannot store the telephone number and email ID in this table. Then we have certain terms called as primary key, candidate key, alternate key, foreign key, and composite primary key. All these are somewhere or the other related to each other. Let me start with the candidate key. Candidate key is all these fields which you see over here, they are called as the candidate keys. Candidate keys are those fields which can stand to be considered as the primary key. So if I have 4 fields over here, I can consider all of them as the candidate keys for me. Okay. Or maybe let's make it more clear. Those particular fields where you find that there is not going to be any duplicacy of data, or there is not going to be any blank data, those fields you can consider that as the candidate keys. They all can stand as the candidate for the primary key. Then what we are going to do is, we are going to, out of all these candidate keys, we are going to decide one as the primary key. The primary key is going to be the one which does not have duplicate data and it does not have blank data. That means it has got the unique data. For every record, it has to be different. It cannot be repeated and it cannot be left blank for any of the records. That's the main criteria of a primary key. So if any field is satisfying that criteria, that can be considered as the primary key. Then what is alternate key? Suppose there were 3 fields I considered, 1, 2, and 3 fields as the candidates for the primary key, out of which I have selected only one as the primary key, the roll number. The rest of the fields, name and class, will become the alternate keys. They are considered as the alternate keys. So the alternate keys are those keys, those candidate keys which could not become the primary key. Primary key is going to be only one in one table. You cannot have 2 primary keys in one table. There is always only one primary key in one table. Then we have got something called as composite primary key. Now, composite primary key is a situation which arises when we don't have any field that can qualify as a primary key, in which case we have got to consider a combination of 2 fields as the primary key. So if I consider roll number and name as the primary key, then that's called as a composite primary key. Or if I consider name and class as a primary key, then this combination of name and class is called as a composite primary key. When the primary key is made up of more than one field, that is called as composite primary key. Then we have the concept of foreign key. Now, foreign key is something which is used for maintaining the relational integrity. Relational integrity in the sense that, suppose there is one more table, which is the canteen table. Now, in this canteen table, I'm going to have, say, your canteen ID, CID. Or if I'm talking about the library table, I will have one primary field over there. But in this canteen, I want the items to be issued only to the valid students of my school. So what will happen? I should also keep this roll number available in this canteen table. So this roll number will come over here. And then rest of the things will come, the item, the quantity, and the price and all that. So what's happening is this canteen table has got CID, the canteen ID, as the primary key. But this roll number which is there, it is the foreign key over here. This foreign key is the primary key of the student table. So understand the concept. The foreign key is used to maintain the relational integrity of the table. That means whenever I'm going to be issuing something, if the canteen ID is C1 and roll number I enter is 56, I will easily come to know that roll number 56 does not exist in my student table. That means he is not a valid student of my school. This transaction should be cancelled. So this relational integrity can be maintained with the help of foreign key. So that's about the foreign key concept. Now, a very important thing, every foreign key of a table is the primary key of another table. So if this is the foreign key over here, this is the primary key of this table. So only the primary key of one table can become the foreign key of another table. To make this entire concept, there are a number of candidates who stand for election. So those are all the candidates for the Prime Minister's post. Out of all these, only one person can become the Prime Minister. Not everyone can become the Prime Minister. The rest of the people who were the candidates, they were also equally qualified to become the Prime Minister, but they could not become the Prime Minister. So what are they? They are all the alternate keys. They are the alternate Prime Ministers. And who normally deals with the other countries? It is the Prime Minister of a country who would be dealing with the other countries. So he becomes the foreign key. Then there is something called as data type. Now, data type is normally used to identify what type of data we are going to store in a table. There are different types of data types. One is numeric, where we are storing only the numbers. Then alphanumeric, where we are storing the alphabets and the numbers. Then binary, where we are storing either 0 or 1 or true or false. Date and time, where we are storing the date and time. Say, for example, date of joining, date of birth. So date and time. Then other variable types like storing the pictures and anything else, right? So this is called as the data type. Now there are different categories. These are the broad categories of data types which we have. When we talk about each individual category, in numeric data type, we have got tiny int to store small numbers from 0 to 255. So if you want to declare a field, say for example, only the roll number, and there are only 20 students in a class, so you can have tiny int as the data type for that particular field. If you want more than that, you can go for small int. If you want still bigger than that, you can go for integer. The alphanumeric data types, normally, most commonly used ones are char and varchar, but we also have long varchar and varchar ignore case. But the most common ones are char and varchar, which are normally used. And this is an example of a table.